Friend, today discussing topic is about the substations. Different types of substations nowadays are constructed. The most important and reliable substations is GIS. What is the full form of GIS? GIS is the gas insulated switchgear. It is not the substations. GIS is the gas insulated switchgear. All the parts of one AIS bay are accumulated together and connected tightly with each other, separate units to form a bay or gas insulated switchgear. Inside the GIS modules, there are one bay, that means disconnectors, earth switch, circuit breaker, CT, again disconnectors, then bus bar, and the output of it is in cable sealing, or it may be the output type bushing as per the requirement basis. So it is a technological enhancement from AIS to GIS. So what is the difference between AIS and GIS? The three types of technology nowadays we are using: AIS, GIS and MTS, air insulated switchgear. Generally, previously different types of substations and power plant equipments are being installed as per the insulations considering air. So, in case of the AIS substation, air insulated switchgear substations, that is circuit breaker, CT, bushings, isolators, all are insulated from phase to phase, and from phase to phase inside is the air. That's why it's called the air insulated switchgear substation. GIS, gas insulated switchgear substations. All components are insulated by SF6 gas. Insulation within the phase and between the phase. This is the main funda. Insulation within the phase and insulation between the phase. What is MTS? Mixed technology switchgear. Generally, the mixed technology switchgears are not being used in India. Now, the most important substation switchgear is GIS, gas insulated switchgear substations. So, what is the basic difference between insulations within the phase and insulation between the phase? Suppose, as for the example and for easy understanding, I have drawn a circuit breaker. Three phase circuit breaker. The three pole are present here. It is the 145 or 132 kV circuit breaker. Inside it the SF6 gas present. Inside the three pole interrupters, the SF6 gas present. So it is the phase insulation between the phase. So we are using as a arc quenching medium SF6 gas in between the phases. Here our insulation between the phases, this is the red phase, yellow phase and blue phase. So this is the red phase and yellow phase. In between no SF6 gas is present. Here the air is present. That's why it is called the air insulated substations. Or for the case of the GIS substations, these two phase, in between two phase SF6 gas is present. Okay, in these two phase SF6 gas is present. That's why it's called the gas insulated substation. The insulation between phase to phase is SF6. Here air insulated substation, phase to phase inside air. So air is an insulations. Here is the SF6 is an insulations. I have drawn a gas insulated switchgear assembly. Different types of assemblies are here. The disconnectors assembly. Both are the disconnector assembly. Disconnector means the isolator. disconnectors. Here it is as this name is disconnectors. And here from second, the circuit breaker is present here, the interrupter inside it, and the SF6 gas is just filled for the arc quenching medium. Here the DM box for the air insulated substations. We have seen that a DM box is present. What is the function of the DM box? It is being used for the spring charge, it is being used for the on off of the circuit breaker. So it is the drive mechanism box. For this circuit breaker, this drive mechanism box is fitted on the upper side of the circuit breaker. After that, a CT. As per your requirement, the CT is present here, a rod is present, and the secondary core, a rod is inside present, and the secondary core are just as like as these. If it is 2 core CT, if it is 4 core CT, all the core are present, and a secondary junction box, this is the JB. Secondary JB, all the connections is just keep here for the protection and for the metering. For the protection and metering, as like as this CT is present. So inside this CT, different types of connections are there. This is the VT, voltage transformers, and here also the disconnector is present and a cable sealing is present. Cable sealing is if any output cable is connected with this cable sealing will be present. If this bay is used for the transformer, so the GIS to bushing, air bushing is present for the connection of the transformers. And here the all the switch gears or all the modules or all the units are metal encapsulated compartment, are placed inside the metal encapsulated compartment. GIS is subdivided into different modules and zones. Density monitor for individual modules. Individual modules has individual SF6 monitor. This one, all are the different modules. So different zones and different modules has different density monitor for SF6 gas. Okay, the connection with the transformers, oil to SF6 bushing and air to SF6 bushing. Generally, air to SF6 bushing has been used for the connection with the transformer. As the dielectric property is better than the air, the SF6 gas is more reliable and safe for operation. And the GIS is smaller than the AIS. That means the GIS substation, GIS gas insulated switchgear substations is smaller as compared with the AIS substations, because for the air insulation space requires more and for GIS substation space requires low, as the dielectric property is better. So the more safer as everything's insulated by the SF6 gas. Example for the space requirement, if we want to install a GIS substation, the 10 feet to 10 feet one room is required for 1 feet room. One room is required for installation of 145 kV GIS bay. Okay, and for the AIS, 10 feet into 10 feet, 10 or 12 rooms is required for the AIS, because the air insulation, because the SF6 insulation. It is not the new technology or the enhancement, it is being used. It was being used before the 30 to 40 years. Nowadays we are preferred for the GIS because for the space requirements. In the busy city or in the congested area, the space is not available, so one room or a big room is required for installation of the GIS panel or GIS modules for the fulfill our requirement. That's why we are being referred nowadays the GIS substations. It is being used from 72.5 kV to 800 kV substations or power plant or industrial applications, whatever it is being installed. costly than the AIS. It is too much costly than the AIS. And the manufacturers, we are now discussing about the manufacturers of the GIS technology. Nowadays, the Siemens, Hitachi Energy, GE, General Electric, CGL, Compton Gibbs Limited, Toshiba, Schneider Electric, and Hoshang are being manufactures the GIS modules for the installations as per your requirements and as per your specifications or guidelines. You can follow or contact with these manufacturers for the installations or for starting of your substations, GIS substations. Applications: it is being used for the power transmission and distribution purpose, industrial integrated integration of renewable power plant, and offshore connections with the hydel plant. All types of applications are here. So friend, if you interested to show my video, please subscribe my channel and press the bell icon for more updated informations about the GIS and AIS. If you interested, please share my video with your friends and colleagues. I have installed different types of video related to electrical engineering, related to substation, related to power transmission, distributions, and my practical experience with the AIS substation, 220 kV circuit breaker, 132 kV circuit breaker, battery earth fault, different type of PD, how the partial discharge calculations you can measures, how LCM, LA leakage current you measures, how the earth resistance you can measure. So different types of measurements you can done by and get knowledge from my channel. So please subscribe my channel and press the bell icon. Thank you very much friend for watching my video. Thank you.